Hello friends, I welcome you on my YouTube channel Study Maths with Asif. So friends, in this video I will discuss real line and intervals, open intervals, closed intervals, semi-open and semi-closed intervals. I will discuss these intervals here. So before starting this video, I request you press like button given below and share this video with your friends. Also, if you are visiting this channel first time, please subscribe this channel and hit the bell icon for receiving notification of the latest videos. So friends, now let's start. So you see the definitions of the intervals, right, are on now on your screen. So please read first. It is closed interval, then open interval, half open interval, then a real line finally, right? So if I talk about the closed interval, it is denoted by these brackets, square brackets. So what is the purpose of using these square brackets? See, when we use the square brackets, so we include the endpoints as well as all the points inside the interval. You see, from here to here, these are the points which are included in this interval, right? So when we talk about the open interval here, so here it will include all the points between A and B, but it exclude the endpoints. So it is written in this way. Now when we talk about this half open interval, so half means one of the endpoint is open. So here this first endpoint is open, so it is defined in this way, and this hollow circle you see represents the excluded A point, and B is included because this is the bold, right, circle. Now if you read this second half open interval, here A is included and B is excluded. So if I am talking about 2 points, it doesn't mean all the points are not there. There are infinitely many points between these 2 points. इसके अंदर बहुत सारे points हैं, right? A और B के अलावा. तो अगर आप इसको क्लोज इंटरवल बोलते हैं तो वी इंक्लूड द एंड पॉइंट्स. तो ये जो आपको डार्क बबल दिखाई दे रहा है ना, इसका मतलब है कि एंड पॉइंट्स आर बीइंग इंक्लूडेड एज वेल एज ऑल द पॉइंट्स विच आर इन द इंटरवल. Alright, now if you see this kind of representation, it represents, we are talking about the point which are less than equals to x, right? So you see A पर जो है यहाँ पर ये it cannot go beyond A, see, but on the right it is open. So situation will be like this till infinity. So this is simple definition of the interval, and I will give you the example, right, on the number line. Then you will appreciate this, right, much. Now let's move on. So before starting the interval, I will discuss the number line. So we are familiar with the number line. See, this is corresponding to the line which we write in horizontal form, and right, this is written in this way. ठीक है, इसको हम इसको ऐसे रिप्रेजेंट करते हैं. तो इसको आप डिवाइड कर लेंगे तो 0 बीच में आ जाएगा, विच डिवाइड्स दिस लाइन इनटू 2 इक्वल पार्ट्स. 0 के राइट में होंगे दीज आर द पॉजिटिव नंबर्स और पॉजिटिव पॉइंट्स, एंड 0 के लेफ्ट में जो होंगे नेगेटिव नंबर्स और नेगेटिव पॉइंट्स होंगे, राइट. सो आई विल एक्सप्लेन, राइट, हाउ मेनी नंबर्स आर देयर ऑन दिस नंबर लाइन. Then you will surprised to know there are infinitely many numbers between 0 and 1. Similarly, there will be infinitely many numbers between 1 and 2, 2 and 3. Similarly, on the negative numbers, right? So that I will discuss. So before going into that, let's revise how do we denote the real number. So it is the union of rationals and irrationals, right? So I have written them here. So any real numbers, right, we define by using the rational, set of rational and set of irrational when we take their union. Okay, so this is all about number line. I hope you understand. Now let's move on. So how we obtain the interval from the number line? Say for example, I have zoomed in this the space from 1 to 2, between 1 and 2. So I am considering, right, how many numbers are there between 1 and 2, including 1 and 2 that I will discuss, right? So you see, when you zoom in, such डिस्क्रिप्शन यू सी बिटवीन 1 and 2, इतने सारे नंबर आपको दिखेंगे। ये तो सिर्फ एक एग्जाम्पल है जो कि मैंने सिर्फ 1 पे ही उसको स्प्लिट किया है। आई हैव टेकिंग द स्टेप ऑफ 0.1, राइट, इक्वी स्पेस्ड है, बट यू कैन टेक 1.001, है ना, यू कैन टेक 1.2, 1.3, एनी ऑफ द split you can do here. So what fact we follow here? If you see, the fact says infinite number of rational points lie between any two different rational points. So whenever you have two rationals, so these are rationals, any number, right, natural number, integer, these are rationals. So any two rationals, there exists infinitely many rationals between these two rationals. First fact. Second fact, there is at least one irrational between two rationals. That means like rationals, there are infinitely many irrationals as well. So I will make use of this these facts to talk about the intervals, right? So when you see these facts, that means what? Interval will contain infinitely many rationals as well as irrationals. So I zoom in now on the next page, this, right? Then I'll tell you in terms of interval, how do we write it? So when you define this in terms of interval, please look at, if it is closed interval, so it will be written in this way: all those real numbers which lie between 1 and 2 and including 1 and 2, right? So this is closed interval. Similarly, when you see the open interval, these are represented by these symbols. तो यहाँ पर क्या फ़र्क है? We are not including the endpoints, we are excluding the endpoints. Otherwise, all those elements you see in the closed interval will be here. So what is the difference? Difference here will be the endpoints only. But when we talk about the total number of elements here and here, these will be infinite. So when you have infinite number of elements and you deduct finite number of elements, it will not make any difference, right? Now similarly, if you see half open and half closed, sometimes we call this as half open, half closed, or open on the left and closed at the right, right? In this way you can define this, and this is closed on the left and open on the right. So when you define them, close means we are including this, open means we are excluding the endpoints. Otherwise, the points which are right inside 1 and 2, these are infinitely many points, will be included here, right? So you see this, and also real number can also be represented by the interval. So I am writing this by using open interval, because infinity you cannot include inside the interval because these are not real numbers, right? So in this way we denote the intervals. Now let's move on. Again, if you zoom in between 1.1 and 1.2, I just wish to make you understand. If you zoom this place, right, again you see this, such elements. So again you can apply the this process. You can define them in this way as these intervals are defining, right? So what do I mean to say? What I told you before in case of facts, between two rationals there exists infinitely many rationals, or between two rational there exists an irrational. That means these irrational will also be there. Getting or not? If you see them, these irrational will lie between 1 and 2, because these are 1.4, 1.72. So these will be the irrational which will lie between 1 and 2. So here these irrational will lie. So I just took this example. If you multiply this by, say for example, under 2, and if you see this as 5/6, for example, so again this number will lie here. So infinitely many irrationals, that's why we call this, right? So I took this for the sake of demonstration, 2 examples. You can take other examples as well. So I hope, right, you understand something here in case of intervals and real line. So intervals, right, these are the part of the real line, that's it. And how many elements intervals, right, have? You see there are infinitely many elements, means infinitely many irrationals and irrationals. So I discussed these representation and all. So thank you so much for watching this video. If you like this video, please subscribe this channel and press the like button and share this video with your friends. So I'll meet